This is a walkthrough of the Cisco Packet Tracer Lab 5.3.1.3 in the CCNA Routing and Switching Introduction to Networking version 6.0. The purpose of this lab is to understand the addressing on layer 2 and layer 3 in packets traversing through a network, and what happens with the addressing. So we have a topology with two subnets. We have one single router. This means that we have one IP network here, that means that we have one IP network here and one IP network here, one to the left and one to the right, and one router up here. And the communication is on layer 2 inside of each network, and it's routed up here. So we are asked to open a command prompt on the machine called 172.16.31.2. So we will do that. And we are asked to ping 10.10.10.3. So we are creating traffic between this guy and this guy. And first, before starting the ping, we're asked to change to simulation mode in Packet Tracer. So we do that in the lower right corner of the Packet Tracer main window to simulation, and we get an extra window here showing us the PDUs going through the network. And we do a ping 10.10.10.3, and we see that there's a PDU here. And let's see what we are asked to do. Click on the PDU and note the following information from the outbound PDU layer tab. The outbound PDU. So the outbound PDU layer tab is here. No, it's here. Okay, sorry. We can see that the PDU, the packet is sourced to 31.2 on layer 3. Actually sourced from and destined to 10.10.10.3 as expected. And we press capture forward, and each time we press this button over here to the right, it will traverse one hop. So the packet is in the hub, and we can see in the hub that the hub is working on layer 1 because it can not see anything inside of layer 2 because the hub is totally stupid. So it sends the packets out on all ports. As we can see here, we get a copy down to 31.3 as well, and one up to the switch 1. And if we look at switch 1, we see that the switch is working on layer 2, and it has a Ethernet header where the source is 1DA7. Let's look down here in the machine to see what MAC address we have. So I will actually stop this simulation. I will stop the simulation to look at a few addressing first. ipconfig/all to see that our MAC address on the physical address on layer 2 is ending with 1DA7. So let's write that down in the topology drawing. So we have this machine and it's 1D A7. It's the ending of the MAC address. Let's have a look at the MAC address for the destination machine as well, while we are at it. So we do that, and we look at ipconfig/all, and we see that the MAC address for the 10.10.10.3 is ending with 572B. 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 Okay, and the router. Let's have a look at the router as well, just to see what happens before we start doing the pings and look at the configuration. CLI show interface. First of all, show IP int brief. We have an interface 172.16.31.1. It's FA1/0. So I do show int FA0/1, sorry. And it's administratively down. How can that be? Okay, zeros. Two different interfaces. 1/0. And we can see that the IP address up here is this one is 31.1, and on layer 2 the MAC address is ending with 741A. 741A, as we can see here. We have that here. Okay. And we look at the other interface. Which is 10.10.10.1. It's a fast Ethernet 0/0. So 0/0, and we can see the IP address is 10.10.10.1. So this one is 10.10.10.1, and on layer 2 it is ending with 2401. 2401 on layer 2. This address on this interface of the router. So now we can have a look at the packets flowing through the network. We can close this one, and we do another ping. First we go to simulation mode, and we make a new ping. 10.10.10.3. And we move that window away, and we will see here, if we look at the PDU on layer 3, it is destined for 10.10.10.3, and the source IP, layer 3 source address is 31.2, which is the source IP of the machine. On layer 2, the destination address, the MAC address destination on layer 2 is 741A, and this is the trick to understand that on layer 2 the addressing on layer 2 is inside of the layer 2 network, which means that the destination address on layer 2 for the packet going out from this machine is the router, because it's the default gateway. So the layer 3 destination is the end machine on the other side of the router, but on layer 2 the destination address is 741A, and it comes from the source layer 2 address 1DA7, which is the machine. Okay, I swapped this machine here. We're talking about the 31.3, so we're talking about that one, and it's 31.2, not 3. Okay, never mind. We'll click the forward button, and we see that the packet moves to the hub, and on the hub, since it's a layer 1 device that does not look into the packet on layer 2 as well at all, it does not care about the destination and source addresses. So it does only know that the port came in on one port, and it should send the packet out on all other ports. So it do that, and we see that it sends a copy of the packet down to 31.3 as well, and one up to the switch. If we look at the switch, we can see that it looks at the destination address on layer 2. It works on layer 1 and 2, and the destination address is the 741A. So it sends it out. I'm not sure if we can see the cam table here. I don't think so. Yeah, we can try. I don't think we can do that. Okay, never mind. Yeah, actually we can. We can look here. Show MAC address table. Dynamic. We can see in the cam table of the switch that it already knows that the MAC address 741A is on the port FA0/1. So it sends the packet out on that interface. Now it comes to the router, and we can look in the router to see that the inbound PDU, it has a destination of 741A, which is the router itself, and it comes from the 1-day A7, and it works on layer 3. And we can see here that it does not change anything on the layer 3 header, at least nothing that is visible in this picture. It changes the time to live counter, but and the layer 3 checksum, but nothing about the addressing. So the layer 3 addressing is not changed by the router. It would not be changed at any time if it was not for NAT, which is not included in this topology. So the outbound addressing is the same as the inbound addressing on layer 3. So the layer 3 source and destination is unchanged during the entire travel of the packet, while the addressing on layer 2, after the packet is being routed and when it is sent out on this left interface, it has a source layer 2 address of 2401, and it has a destination MAC address of 572B. So when the packet is on the left side of the router, it has this address as a source on layer 2, and this address as a destination on layer 2. So the layer 2 addressing is local on each subnet, while the layer 3 addressing is globally not changed during the travel of the packet. So we can continue to click to see what happens. The packet is sent to the switch, which probably knows where to send it because of the destination MAC address. And the access point, let's have a look at that one. We can see here that this is an access point that is as stupid as a hub, actually, because this access point does not care about MAC addresses. So it sends the packet out on all ports. So since it's in the air, it cannot change. It cannot be more selective than that. So it sends the packets out on to both the machines, but only the right one cares about it. So we can look at the packet here and see that the layer 2 is wireless, and the let's see, the layer 1 port is wireless as well. Okay, so, and we could do the same in the other direction. We can speed this up a bit to see that it sends the destination to the packet to the switch, because it knows that the destination is the on that port of the access point, and the route. It goes to the router and it goes to the switch, and the switch will only send the return packet to the hub and not to the other machines, and the hub will send it out to both. So this is how a ping works, and after that we would have one reply down here, and we have, yeah. Okay. So we can speed this up a bit. So this is how a packet is traversing the network, and the important thing here to understand is the different layers, layer 1, 2 and 3. And let's have a look at the questions in the part 2. I skipped filling out the spreadsheet with addressing because it's so damn boring, but you can do that if you want to. So let's see here. First of all, number 1, were there different types of wires used to connect devices? We haven't looked into that because it really doesn't matter, but we can see on the topology that this line here is red, and we can see here that red means fiber and black means copper. So the answer to that is yes, copper and fiber is the answer to question number 1. Question number 2, did the wires change the handling of the PDU in any way? I guess they mean that does it matter if we're using copper or fiber? And the answer to that is no. Nothing happens. The packet, the PDUs are not changed. Its content is not changed because the media changed between copper and fiber, because it's the same Ethernet. So answer to that is no. I can write it down. First of all, yes, copper and fiber. Answer to question number 2 is no. Did the hub lose any information given to it? Strange question. Why should it? No, it did not. What does the hub do with MAC address and IP addresses? It does nothing. It doesn't care. It doesn't know about a MAC address. It doesn't know about addressing at all. It just cares about electrical signals, so it does not do anything. And number 5, did the wireless access point do anything with the information giving it to it? Yeah, since it is not Ethernet on the this is Ethernet, and this is 802.11 wireless, it changed the format of the packet to wireless. So the answer yes is it repacked it as a wireless 802.11 packet. 802.11. Yeah. Was any MAC address or IP address lost during the wireless transfer? No, it was not, because the addressing was intact during the travel. Otherwise, it could not reach its destination. So, and what was the highest OSC layer that the hub and access point used? It only works on layer 1. It's the physical layer. It doesn't care about MAC addresses, and it does not know about Ethernet frames. Did the hub or access point ever replicate a PDU that was rejected with an X? We didn't see that, but the thing is that the access point and the hubs always replicate everything that comes into them. So the answer is yes. The hub and access point cannot be selective. It replicates whatever comes in to all other ports. When examining the PDU details, which MAC address appeared first, the source or the destination? We did not look that deep into that, but you can scroll back to reverse the video and look at when I showed you the PDU details, that in the header format the destination is first. So the destination IP, destination layer 2 address comes first in the layer 2 header. And why is that? It's because if it comes as early as possible when it comes into a inbound into a device, the device can handle it as soon as possible. So in a good switch, the packet can be switched as soon as the device has read the destination MAC address. And if that comes before the source MAC address, it can handle that faster. So that's why. And the source MAC address is totally irrelevant for switches. It doesn't care about that when it comes to traffic forwarding. It cares about the source addresses to learn and fill out the MAC address table. But the most important thing is the destination, to be able to handle the traffic as fast as possible. Okay, so that was answer to question 10. I don't bother writing that down. You heard what I said. Question 11. Was there a pattern to the MAC addressing in the simulation? Was there a pattern to the MAC addressing in the simulation? So if there's any logic in choosing the MAC addresses, I guess the answer is no. The MAC address is based on two parts. The left part is the vendor part, and the right part is random. So there is no pattern in that. They should look randomly selected. Okay. Did a switch ever replicate a PDU that was rejected with a red X? I did not see a switch receiving a PDU that was rejected with a red X. I really don't understand the question. But since this switch is intelligent and smart, it it does not replicate anything that is unknown and that is broken or anything. So the answer to that is no. The switch is a smart device. Every time that the PDU was sent between the 10 network and 172 network, there was a point where the MAC address suddenly changed. Where did that occur? Yeah, it occurred on the layer 3 forwarding device, the router. So the router changes the layer 2 addressing, both the source and destination. Router, as we see so before. So when the packet was in this part of the network, it used this as a source and this as a destination. When the packet moved over to this part of the topology, it used this as a source and this as a destination. While all the time it used on layer 3 the IP address of this machine as a source and this IP address as a destination. So they changed the layer 2 addressing. And number 14, which device uses MAC address starting with 00D0? 00D0. I didn't see that. Maybe that was a reason to fill out the topology or the addressing table. I did not do that. It was obviously not. Let's have a look at it. Let's have a look. 00D0. It is not the machine, the source. It's not the source machine. Let's have a look at the destination machine. 00D0. This one 0060. So I guess it's the router. 00D0. And I guess the point is that this 00D058 means it's a Cisco device. So it's the vendor ID of those MAC addresses, 00D0, and maybe even all MAC addresses that begins with 00D0 belongs to Cisco. So I guess that was the answer. Which device uses MAC addressing starting with 00D0? Router. And to what device did the other MAC address belong? Yeah, it was between the sender and receiver, source and destination. So we have MAC addresses for the router, for the source, and for the destination. This drawing is getting blurry here. Okay, did the sending and receiving IPv4 address switch in any of the PDUs? No. There was no change of IP addresses, and there should not be unless we're running NAT, network address translation. On question 17, if you follow the reply to a ping, sometimes called a pong, never heard that actually, do the sending and receiving IP address switch? Yeah, because if the packet goes, if the packet goes in one direction, let me change the color of the drawing here. If the packet goes in this direction, oh, that was a bad color. If the packet goes in this direction from right to left, this is the source and this is the destination. And if the packet goes the other way around from the left to the right, the left one is source and the right one is destination. So yeah, it swaps depending on in which direction it goes. Obviously, this was quite a strange question with an obvious answer, I think. What is the pattern to the IPv4 addressing in the simulation? That's a strange question. What is the pattern to the IPv4 addressing in the simulation? Actually, if I get this question without the key that I have, I would have no idea what to answer. It's a really open question. In the answer key, which I have actually, it says each port of a router requires a set of non-overlapping addresses. Duh. Yeah, a router is a device that belongs to more than one IP subnet. So each router interface needs to be in different subnets. So that's the question to that, answer to that. 19. Why do different IP networks need to be assigned to different ports of a router? Because the function of a router is to interconnect different IP subnets. So that's why you need to have router interfaces in different subnets in order for it to route. If it would have more than one interface in the same subnet, which it can't, it would not have been able to route. So it's a gateway between different IP subnets. Last question. If the simulation was configured with IPv6 instead of IPv4, what would be different? The addresses. The addressing would be different. We would use longer addresses with hexadecimal addresses instead. But everything else would be the same. The switches and the access points and the hubs would not have a clue if this is IPv4 or IPv6. Because IPv4 and IPv6 are two different protocols on layer 3. And layer 3 is totally invisible for devices that cannot handle layer 3. And switches are layer 2 devices, and hubs and access points are layer 1 devices. So in order to change to IPv6, we would have needed to change IP addressing on the devices, on the machines, on the source and destination, and on the router. But the other devices in between, the switches and the hubs and access points, does not care about that at all. So this was a quick walkthrough of this lab, and the lab was again called 5.3.1.3, identify MAC and IP addresses in the CCNA routing and switching 6.0 material introduction to networking. Thanks for watching.